All right, let's take a look at reflection and refraction. Okay, 4 questions, which also will show up at the end. We need to know what the normal is. We need to know what the law of reflection states. A ray of light striking a mirror at an angle of incidence of 60 degrees would reflect off the mirror at an angle of reflection of blank. So we need to understand what that concept is. And if you don't know what angle of incidence is, we're going to go over that too. The law of refraction, also known as Snell's law, what is that? Okay, so we'll go over all this stuff. Okay, so we got a bunch of concepts here, and the law of reflection looks like it should be at the bottom and is kind of fallen off the screen. So we have what, 1, 2, 3, 4, 7 concepts to go over here. So we'll start with the incident ray. So the ray of light that initially hits a polished surface, that's called the incident ray. The ray that gets reflected away is called the reflected ray. Kind of like exactly what it sounds like, right? The point at which the light hits the surface, that's called the point of incidence. If a line is drawn perpendicular to the point of incidence, that's called the normal. Okay, and so again, that kind of goes back to one of our questions. The normal is an imaginary line that is drawn perpendicular to the point of incidence. Okay, so that's important. That's a very important one to know. An angle of reflection measures the position of the reflected ray in relation to the normal. The angle formed between the normal and the incident ray at the point of incidence, that's called the angle of incidence. And then finally, the law of reflection. According to the law of reflection, the angle of incidence is equal to the angle of reflection. Okay. Now, a little bit about refraction of light. When light passes from one medium to another with different densities, its path gets deviated. So this is called the refraction of light. Components included in refraction of light are incident ray, refraction ray, normal, and the point of incidence. Okay, and then like this is a common example, your reflection in a spoon or really just any curved surface. So let's talk about this for a minute. So if you look at your own reflection on the inside of a spoon, you'll end up seeing an image that is upside down and backwards. The incident rays from the top of your head will be reflected towards the bottom. The incident rays from your chin will be reflected towards the top. Because the spoon is curved from top to bottom, your reflection appears upside down. The law of reflection still applies for curved surfaces, but the normal on a curved surface is different depending on where the ray happens to strike. You have to think of one curved surface as sort of a combination of tiny flat surfaces. Each little piece of the curve has its own unique normal. And with that, we jump right back into the questions. So a nice short little video and great time to hit that pause button and test yourself out on these 4 questions.